Right, hello and welcome to another Dauntless Development video. Now today we are going to be looking at, we're going to be starting off on a new series. This is going to be an FPS tutorial. So what we're going to do is we're going to make a character controller, so just a player that we can move around with a weapon that we can shoot. We'll make a few different weapons in a few different ways. We'll have ammo. We'll have pickups, so you can pick up ammo and you can pick up like different things, maybe coins or whatever. So things you can collect off the floor. We'll have enemies that you can shoot. We'll have some form of objective, and we'll have score. So it's just going to be a simple kind of prototype FPS kind of thing. We're not making a whole game, but yeah, we're going to make just a small kind of FPS mini game, just to kind of obviously show some of the methods that you might use when you're working on an FPS. So let's get started. Now to start off, you'll obviously need to make yourself a Unity project. Obviously this is in Unity, I should specify. And I'm using Unity version 2019.4.10 F1. Now this is the long-term support version of 2019. So it's probably at current the most recent stable version of Unity. So obviously once 2020 long-term support comes out, once the 2021 versions start coming out, I'll probably move to that. But for now, I like to stick on the LTS, the most recent LTS version. So some things might differ slightly, but the majority of things should be exactly the same. Okay, so let's get started. Now we're going to start off by creating our player. Actually, before we create the player, so we're not going to start with the player, we're going to create the ground first, just so we've got somewhere for the player to walk around on. So we're going to just make a right click on the hierarchy, 3D object, and create a plane. So as you can see, it spawned all the way down there. That's because for some reason when you spawn an object in Unity, it spawns kind of where your camera's looking at a certain distance away. I'm not sure how it decides how far away, but you just want to reset all that to 0, because it's best to work from the center, because otherwise if you start working from some random location, then it might mess things up a bit. It's a lot more simple to just work from the center point. So there we go. So we have some ground. So now we can just make a player. So we're going to just make a capsule. So a 3D object again, and we're going to make a capsule. And we're going to just change the name of this capsule to player. Fairly straightforward stuff at the minute. Obviously, it might not be straightforward for everybody, so I'm just going to kind of go through everything. But for some people, obviously, if you've done stuff like this before, you'll know what you're doing. So I'm just zeroing out all the coordinates right here. It's always something you want to do when you start off working anyway. It's best, I find it best to zero things out and then move to where you want, rather than starting from some random location. So here we go. I've just lifted it so it's sat on top of the ground instead of being through the ground. So this capsule is going to be the player, and what we need to do first of all is if I go over to game view, you can see this is where the camera is. So if we play the game, so if I hit play, this is what we see. So we see the player from over here. Now, since this is an FPS, a first-person shooter, we'll want the camera to be from the player's perspective. Now, in Unity, Z, so this blue arrow, the Z axis is forward. So positive Z is forward. So we'll want the camera to be facing positive Z from the player. So if we take the camera and we just move it further forward, so you can see this camera preview in the bottom, which helps a lot. We just move it forward, move it inside, and then like a little bit closer. I'm going to move it up. And as you can see with this camera, there's this little box here, and this is what's called the view frustum. Now, if you don't know what a view frustum is, it doesn't really matter that much. It's basically just the area in which you can see. So if you imagine that this box here is the screen, so if you were pressed right against something, it would fill this screen, like when it hits this point. So this is the nearest point you can see. and then that's the furthest point, but the furthest point goes on forever, basically. Kind of. It's 1,000 away, because that's the clipping plane. And you can adjust where that is as well. But yeah. So this is kind of just the view area. So you want this as close to the face, like where the face would be as possible. So obviously, if you were using a humanoid as an example, obviously this is just a capsule, so it doesn't really look like a person. But if you imagine that this is a person, their eye level would likely be around this kind of height, maybe a little bit higher. So you want to kind of roughly emulate like an actual kind of human's height. Obviously, it depends on the character. I mean, if you're making a player controller that it's very short, you want to put the camera low down. Well, that's the thing, if you've got a character that's very short, obviously you just want to put it on the face of the character, is what I'm trying to say. So there we go, we have the camera there, but we now need to attach it to the player. So we're going to drag it down onto the player. Now, as I said, this is quite straightforward stuff, so a lot of people, this is fine, but if you're not sure about this, when you make an object in the hierarchy, a child of another object, by dragging it onto it. So you see how it's got a little drop down. This main camera is now a child of the player. That means that whenever the player moves, the camera moves with it. So the camera is now stuck to the player as long as we move just the player and not the camera. Which means that we can, when we start processing input and moving the player around, the camera will move with the player and turn with the player, meaning that it will work straight away. We don't have to do any extra stuff to make the camera work. It just will work. So that is kind of the basic setup there. So we've got, a little bit of ground. So what we can do is we can, I'm just going to save. We can start making scripts. Now, one thing I would advise is when you're working on a project, you can see by default it's giving me a scenes folder to keep the scene in. I would recommend, instead of just dumping everything into your assets folder, making separate folders for different things. Now, you can organize this however you want. For simplicity's sake, I'm just going to, just for grammar. So I'm going to have a scripts folder, and I'll have maybe a models folder, etc. later. Now, it obviously depends on your project and what makes sense to you. You might want to organize things by feature, so maybe you might have various characters. So you might want to have a character folder and then have inside that a character scripts and a character model and a character sounds, etc. Or you might want to just have scripts and then split that into even more folders. But obviously, it's just all up to personal preference. So, I've made my scripts folder. Now, there's a few ways to make a script. You can either go onto the player itself and add component and choose, scroll down and there's new script, and then you can name it here. But since we've got this folder, I think what makes most sense is just so it starts off in here. I'm going to just right click, create C# script. And I'm going to call this player movement. And we're going to open this up. Now, obviously you'll need Visual Studio or some form of IDE. You could use Visual Studio Code, you could use code blocks, you could use, there's another one, I think it's called Rider. I've seen people use, but I think you've got to pay for that. There's a lot of options. Yeah. So, when we open this up, what we see is we got public class, player movement, mono behavior. So all this means here is we've got the script is called player movement and it inherits from mono behavior. So that means that basically it runs on Unity's specific stuff that makes it a script that can run in the world. If you don't have this mono behavior thing, you can't attach it to an object in the world. So what we need to do is for the player, we're going to need some variables. So we're going to need a private, let's say float, movement speed. I'm going to just set this to 10 for now. I'm going to say private, float, turn, speed, and I'll set this to 200. I'm not sure what, I'll change this later. In fact, one thing that you might not know is with Unity, if you have a private variable, that you want to change in the editor, then you can put square brackets before it and you can say serialize field. So I'm going to do that before both of these so I can change them in the editor. Okay, so after we've added these variables, we're going to need to add some way of taking input because we can't really do anything with we can't move the player without actually, well, we can, but we're not going to be able to move the player really without taking some form of input from the user, from the person at the computer. So what we're going to do is we're going to make a couple of functions just because it's tidy. So we're going to make a private void, and we're going to call it, oops, one moment, there we go. Yeah, so we're going to call this private void handle keyboard input. Goodness me. Handle keyboard input. I can't press the right keys. I need to handle keyboard input a bit better. Right. And similarly, we're going to want another function called private void handle mouse input. So, and we're going to just put these into the update function. So basically every update, we're going to just handle inputs. And the reason I'm doing this in functions and not instead of just putting it into the update like a lot of people might do, and like I have done in the past, it's just a lot tidier. So rather than filling your update function up, you can just have all the code down here, and then when you want to look through the update to see exactly what's happening in the update, you just know that you're handling the keyboard input, you're handling the mouse input, and then you're doing whatever else you want to do. So, handle keyboard input, what we're going to do is we're going to say if input dot get key, get key, and we'll say key code dot w. So what we're doing here is we're saying if you detect that this key is pressed, the W key. So there's get key down, there's get key up, and there's get key. So get key down will only trigger once when you first press the button, which would mean that you'd have to keep pressing W to move forward. You have to keep tapping it. Get key up is the same, but when you release it, and get key just means as long as it's currently pressed, keep triggering this result. So this is what we want for our movement. We want to use get key. That is assuming that we're using constant movement. You might have some kind of game where you move in tiles and you might want to only move a discrete amount, in which case having get key down might be correct for you. But for this case, we're going to use get key. So what we're going to do is we're going to say transform, oops, didn't mean to press that, transform.translate, there it is. And we're going to just say, so you need to put a vector 3 in here. So we're going to just say new vector 3. And because we are moving forward, in fact, we don't need to say new vector 3 at all. What would make far more sense, as I said, because we're moving forward, we can say transform.forward. And that way it will always move relative to the to where the player's facing, so we'll move forward. Now what we're going to do now here is we're going to say else if, and we're going to do a very similar thing, so input.getKey, and we're going to say keycode.s. And the reason we're using else if here is because this means that it won't try to move forward and backwards. So if you press both, it'll just move forward. Now, obviously, there's other ways you could handle this to stop it. You could either you can make them cancel each other out, and then you move nowhere at all. You could make it so that you could have like applying a force moving forward and a force going backward, and then it would cancel itself out the same. You could have it maybe based on the first key that's pressed, but for this, we're just going to have it, if S is pressed while W is pressed, it's just going to keep moving forward. Because generally, well, there's no reason you'll want to try to move forward and back at the same time, other than just seeing if you can. So by restricting it, you're not restricting your gameplay, and it makes it simpler and probably less prone to error. So we're going to do the exact same thing. In fact, I'm just going to copy this line. So you could do the same. So I'm just going to copy this line, paste it in here. And the only difference is instead of transform.forward, we put a minus sign here. Because there's no transform.backward, we just say minus forward, which obviously the opposite of forward is backward. And we're going to do something very similar for these next two. So we'll say if input, and I might just speed this up just a little bit, or just skip ahead to when I've finished typing this out. So I'll see you when I'm done. So there we go. So as you can see, I've done transform.right and minus transform.right for D and A. As just like with forward and backward, there is no left, there is only right. So we just say minus right, which is the opposite. Now you'll notice that I used an if statement here instead of an else if. And the reason for that is because we want to allow the player to move diagonally. So that means they can press W and they can press D, or they can press W and they can press A, or they can press S and they can press D and A as well. So you can only not move two of the same direction at the same time. So if you pressed all the buttons at once, I guess you'll move forward and right diagonally. But generally, players probably won't be doing that. It doesn't really make sense to do that anyway, so it's not really something you have to worry about too much. But yeah. So we're going to do handle mouse input now as well. Now this is going to be relatively similar. However, there obviously are some differences, because instead of getting a keyboard input, we get the mouse. We get the mouse position / well, we don't necessarily get the mouse position, but we get how it's moving. Yeah. So what we'll say here is if input dot get axes this time, and then we'll say mouse X. Now this in here has to be typed exactly as it is here. Now the reason for that is because I'll show you this in a moment. I'm just going to leave it like this and then just open it up. Yes, so the reason you have to type this exact is because this isn't something that exists in the code. This can be specified by the user. Now, by default, this axis exists, but if you go over to Unity, if it'll open, yeah, and you go over to, I believe it's under Project Settings, and then you go to Input Manager, and you can see that there's all these axes here. So we're using mouse X, and we're going to use mouse Y. So these exist, and these will basically take input from the mouse movement on the x-axis, so you can see that. Now you can adjust these, you can make your own axes, but they have to be specified by their name here. So obviously it has to match this. If for some reason it's different, I'm not sure if Unity in different languages names things differently. So if you've downloaded a different native language, it might be different, but I would assume they'd use the same names universally. But yeah, just be sure to check that just in case. But assuming everything's fine, you can use this get axis mouse X, and if not, you can make your own and just copy what it looked like. So what we can say is we can say transform dot rotate, and what we can do is we can, because input.getAxis actually returns a float, so it'll return a positive or a negative value depending on whether you've moved to the right or to the left. So we want to rotate, and we rotate with a vector 3. So we'll want to make a new vector because we only want to rotate on one axis. So we'll say new vector 3. And we can then say, well, we don't want to rotate in the X, because if we rotate in the X, we'd be rotating, like tilting forward and backwards. We want to rotate in the Y, because that is looking left and right. So for looking left and right, we'll say input dot get axis, and then we can just say mouse X, and then we don't need to put any conditions, and then we'll just say 0 for the next one, and then we put a semicolon on the end. So what this is going to do is it's going to rotate by the amount that the X moves, and we also almost forgot. So when we move, when we kind of translate and when we rotate, there's one thing that we always want to have everything in respect to, and that is time. Now, the reason, so what I mean by that is we multiply everything that we do by time dot delta time. And the reason for that is because if right now it's so right now this will move by a certain amount every time there's an update. Now every time there's an update means every frame. Now the thing is with that is if you move every frame and you have a higher frame rate to somebody else, especially this is like, it's not as much of a problem with a single player game, although it is still a problem. But if you're in a multiplayer game, this is where it's the most important. If you have better performance than somebody else, so say you have a better computer than them and you have 200 frames per second and the other person has 100 frames per second, for example, you move twice as fast as the other person because you have twice as many frames. So you need to multiply by time.delta time. What this means is delta time means the amount of time that's passed since the last frame. So if there's less time passed, i.e. you're getting more frames, so if you were on twice as many frames per second, there'd be half as much time between each frame, meaning you're multiplying by half as much, which means your speed is always the same consistently. It's always the same with respect to time. And that's very important. One example of where they didn't do this, if you know, is when Fallout 76 first launched. Players, it might not be when it launched, it might be in the beta, they might have fixed it when the game released. But I do remember reading articles that they'd done this, where players would basically look at the floor, meaning there was less on screen, which meant the frame rate went up and they'd get much higher frames, and therefore they'd run a lot quicker and they'd be able to do everything a lot quicker because nothing was tied to time, it was all just tied to frame rate. So that's a big mistake you don't want to make. So yeah, you want to multiply everything by time. Now, one thing I also didn't do, I noticed, is I didn't multiply by my movement speed variable. So that is important as well, because obviously we want to be able to set the speed that they move at. So I'm going to also multiply all these by movement speed. So the rotation speed, I'm going to multiply that by time.delta time as well. And I'm also going to multiply by turn speed. So now it'll be relative to the turn speed and to time. So we'll do the exact same thing for the other axis. Although for the other axis, we're going to need to do something different. Because if we rotate it just as we're doing right now, when we use transform.rotate, it would tilt the player forward and backwards. Like I said, because when we're looking up and down, we're rotating on the x-axis. And we don't want to necessarily tilt the player, because I'll show you what that would do. If we say looked up, it would make the whole player, and let's just put, where is it? There it is. It would make the whole player do this, which obviously doesn't really look right, because say if this was a player model and they had legs, it would mean every time you look up, you stuck your legs up in the air, which doesn't make a lot of sense. Now, obviously, if you've got a fully rigged character, you might be able to just turn the head, and it might, through inverse kinematics, it might kind of bend the neck and the back and everything. It might work fine. But if you're working on just a solid model like I am, you'll want to turn the camera instead of the player itself. So we'll want a reference to that camera. So we're going to just go up to the top and we're going to make a public, just because it's easier, camera. And I'll just call it cam. So what we're going to do with this public variable is we're going to go to our player, and we're going to drag this script on now because we're going to need to do it. And we'll just drag this main camera onto the cam slot here. So what we can do now is we go into if input dot get axis, and then for this axis we're going to use mouse Y. So mouse Y is when you're moving up and down on your with your mouse, and obviously positive is up and negative is down. So I think we'll just have to double check that. But yes, so we're going to say, instead of our transform, we're going to say cam.transform, and then we're going to say .rotate, and then we're going to have to rotate around the X. So we're going to need to, actually, I believe, can we use, we can, I think. I'm just checking. Yeah. Okay, so I made that new vector 3 up here. We didn't actually need to, so I'm just going to delete that because we can just use 3 floats. Although it doesn't matter. It doesn't matter, so I'll leave it. But we can use just 3 floats, so I'm going to just do that for this one. So I'm going to say input dot get axis, and I'm going to just say, oops, missed the shift key there, mouse Y. So just like we did before, this is going to be positive and negative. So this will handle both movements, so we don't need to specify. So we're going to rotate by that. I feel like I am missing a bracket here. And we're going to say multiply by time dot delta time and multiply by turn speed. And then we're going to just say 0, 0. So as I said, with the previous one, I made a new vector 3. With rotate, you can pass in a vector 3, or you can just pass in 3 floats. So for this one, I've just done 3 floats because it doesn't make a difference. It's just less code written. So that should handle all of our inputs so far. So if we test this out, I think this up and down might be backwards. So I'll fix that if I need to, but I'll test it out. So I'm going to hit play. And yeah, it's backwards. So I'm going to just quickly change that. So that it's the right way around. So I'll just hit minus. So there we go. We can look up and down. We can look left and right. And there's one thing I made a mistake with. So you can see that when I'm turning, it's not quite turning correctly. And that is because I'm not moving in the right coordinate space. So Yes, so when I go to here, I can, so when I'm moving, what I can do is I can change, I need to add an extra comma here and just say space dot world. I'm going to do the same to all of them, all of the movement, because this makes it so that it moves in the correct coordinate space, because when we were turning, it wasn't updating where the forward was. So now it should. So if we hit play again, we should see everything is working just fine. Just as you would expect. So we can now move around and it works just fine. Now, if you want, you can do things where you can lock the mouse to the screen if you want. Right now, we're not going to fall because we don't have gravity or anything. This floor is just here for show. We can just kind of float around. But as you can see by the shadow, when I look up and down the... oops. I don't know how I did that. When I look up and down, the player does not move. So it doesn't, I won't have my legs stuck up in the air if I was an actual humanoid model. But yeah, so that's kind of just setting up the basic player character for now. We'll add like a gun next time. But that's all for today. So thanks for watching. I'll see you next time.